To explain the model that we're going to use for the final competition, then we could define each turn. We would have a state and an action to be taken, and this would be saved in a vector called x. If we have a game till turn n, this would become a sequence where 1 was the first turn and n is the turn n. So that if we have, or we could model the probability distribution of the sequence to be a winner given the sequence that we already have, then we could choose the action that maximizes this probability out of all the valid actions. And this is how we're gonna model the system. There are many ways to find this probability distribution, but we use the LSTM. The LSTM is a type of neural network or recurrent neural network that has shown amazing results in evaluating a classification of sequences, and that's the reason why we chose this model. There are some pre-processing, because if this machine learning technique needs a dataset, we had to look for the dataset over the internet. And we found a dataset which is available in Kaggle and has around 25,000 games, which we can transform to 51,000 samples because we can use the sequence for one player and for the other player. And those are the training sets that we're going to use. It's going to be later split to evaluate performance at the beginning, at least. And then when we have transformed, because there's a pre-processing that we have to perform, because the dataset starts encoded with characters, and then we have to basically transform it to have 0, 1, and -1 to be a numerical vector that we can process with a neural network. We used two models, two types of LSTMs, or with more parameters, one very simple with around 16,000 and other which almost 1 million trainable parameters. The reason to do that is to measure how the complexity of the model would affect results for this specific case. And here, after training the model and evaluating the performance in 1,000 games, here are the results. The initial dataset was the one that was downloaded from Kaggle, but there's also a model versus random, which is this model that was trained with the initial dataset playing against a random agent versus another random agent, and all datasets concatenated together. So something that we can see here is that model 2, which is the model with most parameters, have the highest win ratio. But when we compare it to some other dataset obtained, or some small dataset, the win ratio is completely decreased, while in a simpler model, it stays or remains almost the same as the initial dataset. As it can be seen here, the performance or the winning ratio between the initial dataset and the random versus random is almost the same.
Another computational approach, or the other algorithm or model that we have used to solve the problem, the given problem, is the min-max algorithm. So the min-max algorithm, as we know, is one of the simplest mathematical functions used in game theory. It's almost used in any game development which uses a n-player game method. I chose this because because the problem statement had required a background knowledge of Othello game and reverse I agent and how it works. So which I was not quite sure of. So hence I chose a simple algorithm rather than a very complex algorithm. To build or to code would be much simpler, because I would then understand the game much better. The application. So moving on to the application part. Application part is the backtracking. As we all know, it's a backtracking algorithm, which is used in finding the optimal move of the player and the legal move, whether it's a legal move or not. The mathematical form of the min-max algorithm is nothing but proving that the min-max inequality and equality, basically that the min-max of f of x is equal to min-max of f of x, where even if we have two compact convex sets, the max and min, if it interchanged as well, both remain the same. The coding implementation, the whole implementation consists majorly of 5 files. One is the default MyTeam file, board file, board Python file, Othello test, and score. So the default file is a simple file where the main method is defined, and it initializes the game, calling the other methods defined in the other files. And it just initializes the game. So the second file would be the board. This board, I have described the board, the grid, the size, grid size, the color, the tuples, and the two integers